morning. Now, this is part 2 of me showing you guys how to solve polynomial functions. All right, looking at this example, the first question that's being asked is, how many solutions does this function have? Well, according to the highest degree being 3, I'm going to have 3 solutions. Justify your answer using the given function only. Same thing like the last video. The highest degree tells you how many roots your polynomial is going to have. What roots did you find on your graph? So when I go to Desmos and type in the polynomial function, as you can see here, this is what my graph looks like. Now, we just said we have 3 roots, but you only see it across the x-axis at the number -5. That's because the other 2 are complex roots. So my first root I'm going to start off with is x equals -5. What factors are associated with the roots you found? Well, I only found one of them, and like we said in the previous video, the graph crosses the x-axis at those points, well, in this case, just one point, which is also called your x-intercept of -5, 0. We need blank rational roots to divide the polynomial down to a quadratic. Well, like I said in the previous video, quadratic is when it's x squared. This particular function starts off with x cubed. So in order for me to go down to x squared, I only have to go down one time. So I only need one rational root. All right, now let me do my synthetic division. Since you guys have already seen it done a million times in class, I'm just going to go ahead and go through the process where you bring down the first number, you multiply, add straight down, multiply, add straight down, multiply, and then add straight down. So now this is my A, B, and C. Then I'll plug into the quadratic formula. But as you can see, when I typed everything that's under that square root, I got -68. Well, first of all, there's a negative sign, so I need to take out an I. And when I do that, it's going to say 2 plus or minus I square root of 68, because it makes it positive, over 6. But as you can notice, the square root of 68, that's not a perfect square. So that's why I went over to the side and broke it down. 4 times 17 gives me 68. 2 times 2 is 4. And then remember, for every pair, you take one out. That's why I took a 2 outside of the square root, leaving 17 under. So as you can see, I'll have 2 plus or minus 2i square root of 17 over 6. And then I have to do 3 parts of my heart. And the number that divides into 2i, and 6 is 2. So when I divide all of them by 2, I get 1 plus or minus 1i square root of 17 over 3. So when it says to list all of my roots, the first one that I used for synthetic division was -5, and my other 2, I just separated it, was 1 plus I square root of 17 over 3 and 1 minus I square root of 17 over 3. So when I write the complete factorization for -5, just the opposite of that would be +5, so it would be x plus 5. But as you can see, my other 2 roots are complex roots. So I need to go back to my synthetic division. You see I got 3, -2, and 6. I'm going to go ahead and fill in my variables. My highest degree was x cubed, right? In the original problem. 1 less than that would be x squared, and then x to the power of 1, and then my constant. So that will be the complete factorization. 3x squared minus 2x plus 6. And that's it.